Morning, everyone. Um, Today's topic is control rectifier. So, in this lecture, we are going to discuss about what is your control rectifier, what is your rectifier, and where it is used, and what are the advantages and disadvantages of control. So, first we want to discuss about diode and SCR. So, what is diode? Diode is a PN junction device. It has two terminal and two layers. Actually, it has one P layer and one N layer. And P layer means in this lecture we are going to discuss about control rectifier. So, what is first we have to discuss about diode. So, what is diode? Diode is a PN junction device. It means that diode has two layers and two terminals, but it is in uncontrolled device. Why this is uncontrolled? Because it don't have any kind of controlling terminal in its structure. So diode can be used as as a rectifier, but you can't use this diode to in control rectifier. So what is rectifier? Rectifier is basically used to convert from AC to DC. So this is rectifier, and what is controlled rectifier? Controlled rectifier means that we can control the output. So we will discuss it in detail in this lecture. Now, what are the course objective? The course objective of this lecture is that uh, to discuss about the different kind of rectifiers. It may be our controlled rectifier and uncontrolled rectifier and the course of outcome. And I'm expecting after this lecture that student will be able to understand the different type of uh, converters or rectifier, and what is the difference between controlled and uncontrolled rectifier, and what are the advantages, and which kind of power electronic devices are used to control the to making the controlled rectifier. So these are the semiconductor devices, diode, control rectifier, advantages and disadvantages. So first we have to understand that what is rectifier. So rectifier, that the type of input you can see in this diagram, the type of input is a fixed voltage, fixed frequency AC supply. So what is happening? You are getting in the output, you can see that you are getting the DC output voltage, and this is your line commutative converter. Line commutative converter means if you are using AC in your input voltage, then you need not to apply any kind of another commutation circuit, because in natural commutation, because in AC the waveform goes into the negative direction, so that negative voltage can be used to commutate the SCR. So there are different type of line commutated converter. One is your AC to DC converter, AC to AC converter, AC to AC converter at a low output frequency. So first, if we go to the controlled rectifier or controlled converter, so first we have to understand that what is your AC to DC converter. So the diode, if you are using uncontrolled rectifier, or you can simply call it rectifier, then in this case you are using diode, because diode is used to convert AC to DC, but you can control the output of this rectifier because you are using diode. So what is happening that the diode rectifiers are referred to as uncontrolled rectifiers, and the diode rectifiers give a fixed DC output voltage. Each diode conducts for one half cycle, and the diode conduction angle is your 180 degree or 5 degrees. So, if you are using single diode, in that case, what you have to do, uh, in that case, only you can convert the positive half cycle of the AC voltage into the DC voltage. Okay. Now, if you are using, two diodes in anti-parallel, then you can use, then you can convert positive as well as a negative half cycle of the uh, negative half cycle of the AC input voltage into the DC voltage. So diode conduction angle is your 180 degree and pi degree. So diode, why we call that diode is only conduct into the half cycle, because you can see that diode conduct only for half cycle because it is a unidirectional. The current flow in the diode from p direction to n direction, and it can't be, it can, the current cannot be flow in the opposite direction. Okay, so that's why the diode is your one half cycle. Now we cannot control the DC output voltage or the average DC load current in a diode rectifiers. So this is all about your rectifier, or you can say the uncontrolled rectifier. Now, what is your single phase? Now we will discuss about the half wave rectifier and full wave rectifier. So, what is your half wave rectifier? In single phase half wave diode rectifiers gives an average DC output voltage that is equal to Vm upon pi. Okay, we will discuss it later when we draw the waveform of half wave rectifier, and we will analyze this rectifier, and you will see that the output voltage you are getting, which is equal to Vm upon pi. Single phase full wave diode rectifier gives. Now, Now, next is your application of phase control rectifier. So, before discussing any topic, it is very important to understand that what is the importance of that topic. How can we use these kind of rectifiers or diodes in physical applications? Okay, so these are some of applications which is used in which we use controlled rectifiers. So DC motor control in steel mills, papers, and textile mills employing DC motor drives, and AC fed traction system using a DC friction motor, electrochemical and electrometallurgical processes, and magnet power suppliers, portable hand tool drives, and HVDC transmission. So these are, very vast field where you can use the phase control rectifier, and these are very important applications in this uh, technical world now. So, what is the classification of phase control rectifier? According to phases, because the uh, most important thing is that there is a two phases. One is single and three phase, which is mostly used in electrical appliances. So it depends upon the appliance, which kind of supply it requires and how much voltage it is required. So what is your single phase control rectifier and three phase control rectifier? According to phase, we can divide these control rectifier into two parts. One is your single phase control rectifier and another one is your three-phase control rectifier. So, what is your single-phase control rectifier? In single-phase control rectifier, we use one single phase, and if you are using a diode, then you have to replace the diode by the SCR. If you use only single-phase rectifier, then you can use only one diode or diodes. And if you are using three-phase control rectifier, then you are using three phases in the rectifier. Further, it can be classified into the more different kind of control rectifier. Suppose half wave control rectifier, full wave control rectifier. So we can combine this half wave with single phase or single phase half wave control rectifier and three phase half wave control rectifier, or a single phase full wave control rectifier and three phase full wave control rectifier. So like this, we can divide these you know uh, devices into these kind of classifications. So now we will discuss about the single phase controlled rectifier. So what is your single phase controlled rectifier?
Transistor. And you know, in diode, when diode only conduct in forward biasing, because you can see in the diagram that the terminal, the positive terminal is connected to positive terminal and the negative terminal is connected to the negative terminal of the battery. That's why the current will start to flow from P to N. Now, if you reverse the terminal of this battery, the current will not flow through the diode. So this is your forward and reverse biasing. Now, if you combine two diodes, then you will get this kind of a structure. That is your NPN. Okay. So there are two type of transistor. One is your NPN transistor and another is your PNP transistor. So you can see over here, and obviously it will have uh, the large number of electrons, and P will have the large number of holes. So this is your NPN transistor and this is your PNP transistor. They have both have three terminals, base, collector, and emitter, and it is also have base, collector, and emitter. So now we will discuss what is base, what is collector, and what is emitter. And you know this is the symbol of your transistor. Now, so it has three adjacent region of doping silicon, each connected to a lead. So one is your base. Base is very thin layer and it is lightly doped. Okay. Next one is your collector. Collector is always collect the electrons which is coming through the emitter, and emitter emit the electrons. So collector is, as the name is indicates that it collects. Emitter as the name indicates that it emit electrons, and base which is basically used for controlling the output and input signals. So it is very small layer or thin layer which is lightly doped, and highly doped layer is your emitter, and the moderate doped layer is your collector. So from this diagram you can see that the voltage across the base terminal is VB, the current which is flowing through the base is IB, and the current which is flowing through the collector, that is your IC, and the voltage at the collector terminal is your VC, and the voltage at your voltage emitter terminal is VE, and the current flowing through this is your IE, that is your emitter current. So you can see from the diagram that the voltage across collector and emitter is your VCE, and the voltage across base and emitter is VBE. Okay. So VC is always greater than 0 and VB is always greater than 0. Now this is your NPN bipolar junction transistor. So basically NPN transistor is mostly used in many applications. That's why we will discuss about NPN transistor. And the symbol, you can see the difference between the symbols of these two NPN PNP transistor by this arrow, that in this case the arrow is in downward direction, in this case the arrow is upward direction, which indicates that the current direction of the current direction in NPN transistor and PNP transistor is opposite. Okay, because always current flow from positive to negative direction. Okay, so you can see over here that this terminal is positive, this is your negative terminal, so current direction will be this. But in this case, this terminal is positive, this terminal is negative, so current will flow from this direction to this direction. Now, what is NPN transistor? So a thin layer of P type sandwiched between two layers of N type, that makes a NPN transistor. In N type of emitter, more heavily doped than collector, With VC, VC means collector voltage is greater than base voltage, and base voltage is always greater than emitter voltage. So base emitter junction is your forward bias, like this. You can see over here that base emitter junction is always forward bias, means you have to connect N terminal of this NPN transistor to negative terminal, and you have to connect base terminal base terminal to the positive terminal of the battery. So base emitter junction is forward biased, base collector reverse bias is electrons diffuse from emitter to base, from N to P. Because it is, this layer is your highly doped, this layer is your lightly doped. Some electrons actually emit the electrons which is going from N layer to P layer, and collector will collect the electrons. So there is a depletion layer on the base collector junction. No flow of electrons are allowed. There will be a depletion region that no current can flow through this uh, layers like base to collector. But the base is thin and emitter region is N positive, heavily doped. Electrons have enough momentum to cross the base into the collector. So there is always a small base current IB controls a large current IC, right? Now you can see I is equal to IC plus IB from this diagram. IE is equal to IC plus IB because it is emitting the electron. For these electrons, the current is flowing into the base and collector. So I is equal to IC plus IB. VB is equal to VB minus VE, and VC is equal to VC minus VE. IC is equal to beta IB. So current gain. Alpha is the fraction of electrons that diffuse across the narrow base region. Alpha is the fraction of electrons that diffuse across the narrow base region, and 1 minus alpha is the fraction of electrons that recombines with holes in the base region to create base current. The current gain is expressed in the terms of beta of the transistor, often called HFE by the manufacturer. So beta is temperature and voltage dependent. Okay. So this is the equation IC is equal to alpha IE, and you know I is equal to IC plus IB. So I is equal to, you can put IE is equal to IC plus IB over here, and you can take the common IE and you will get this equation. And beta is called your current gain. Current gain means output current upon input current. So this can be represented by this equation, alpha upon 1 minus alpha. So beta is always your temperature and voltage dependent. It can vary a lot among transistor. Common value for signal BJT 20 to 200. So this is all about your NPN transistor. Okay, and there are two type of transistor, NPN and PNP. So we have discussed about NPN transistor, which is very important, and it is mostly used in various application of transistor. Now, transistor configuration. Actually, transistor works in three configurations. One is your common collector, another one is your common base, and third one is your common emitter. So first we will discuss about what is common collector configuration. After that we will discuss about what is your common base configuration and what is your common emitter configurations. So first is first, before going on this, we will discuss that is what is input characteristic and output characteristic, or what is current transfer characteristic. So input characteristics, it will give us the details about the change in input current with the variation in input voltage by keeping output voltage constant. Okay. So in input characteristic, basically we can understand in very easy terms that input means you have to take your input quantities, and characteristics means you have to draw the characteristic between voltage and current. If you are talking about input, then you have to take input quantities like input voltage and input voltage, and you have to keep your output voltage constant. So this is your input characteristic. Now another characteristic, your output characteristic. So it is a plot of output current with output voltage when you are keeping your input current constant. So there are two types of characteristic: input characteristic and output characteristic, in three configurations like common base configuration, common collector configuration, and common emitter configuration. We will discuss uh, both type of characteristic in three configurations: input and output characteristics of transistor. Now, what is current transfer characteristics? This plot shows the variation of output current with the input current by keeping the voltage constant. Common collector. So what is common collector configuration? In this configuration, we keep the collector common in both input and output. So the configuration in which the collector is common between emitter and base is known as common collector configuration. The input signal is applied to the base terminal and the output is taken from the emitter terminal. So this is your common collector configuration. You can see that the collector is common between input and output. So base, this is your NPN transistor. So collector terminal is common for input and output terminal. Now we will draw the characteristic input and output characteristic for this common collector configuration. So in common collector configuration, you can see that the common collector, the input current is your base current, and input voltage is your VBC, like base and collector voltage, and your output current is your emitter current, and output voltage your VCE, means collector emitter voltage. If you want to draw the input characteristic, you have to take input components. Input components mean input current and input voltage. So input current is your base current, and input voltage is your VBC, means voltage and collector voltage. Now, what is your input characteristic? So you can see over here that this figure shows the common collector configuration, which is describe the variation in IB in accordance with VCB. I mean, like how your input current vary with input voltage, if you are varying your input voltage also. So this is your input characteristic for common collector configuration. Now you can see that we are drawing two characteristics. We are drawing two input characteristics, like VCE1 and VCE2. It means you are taking different output voltages, the value of VCE1 and VCE2, where the value of VCE2 is greater than VCE1. So you can see the difference between these two characteristics. If you change the value of output voltage, but it will be fixed. It will be fixed. The output voltage will be fixed, because we have already discussed, if you want to draw input characteristic of your transistor, then input characteristic mean you have to take input current and input voltage by keeping the output voltage constant. So you can see over here that input current is your base current, and input voltage is your base collector voltage, and output voltage is your VCE, collector emitter voltage. So you have to keep the collector emitter voltage is constant, and then you have to see that if you change your voltage, input voltage, then what, uh, how the current will, input current will change. So this is the input characteristic of uh, a transistor in common collector configuration. So you can see over here that when you are increasing the voltage, the current is also increases. For a after some time, the voltage reduces. Okay. Now output characteristic. Now figure below shows the output characteristic for the common current configuration. So you know output current for this transistor is your I, means emitter current, and output voltage is your collector emitter voltage. Okay. So in output characteristic you have to cap the input voltage constant, input current constant. So what is your input current in this configuration? Input current is your base current. Okay. So input current is your base current. So you have seen that here we are drawing three characteristics, three output characteristics, taking different values of IB1 or IB2 and IB3, where IB3 is greater than IB2 and IB2 is greater than IB1. Okay. So let's talk about your first characteristic. So this is your first characteristic where IB1 means input current, means base current is your constant, and you can find the change your output current and output voltage. Right. Now if you increase the base current, the characteristic also getting up, and you will get this characteristic if you take the if you increase the base current. And if you again increase the base current, which is greater than IB2, you can see over here that you will get this characteristic. So this is your output characteristic for common collector configuration. Now, your second configuration is your common base configuration. So you can see in the diagram that your base is common in between input and output. So here, what is your input current? So input current is your emitter current and input voltage is your base and emitter voltage, and output current is your collector current, and output voltage will be your base and collector voltage. Okay. Now if you want to draw input characteristic for this common base configuration, so you have to keep the output voltage constant, means VBC must be constant, and you will find that if you change emitter voltage, emitter base voltage, that how your input current is changing. So let's see in the diagram input characteristic for common base configuration. So for common base configuration, you can see over here that we are taking two constant voltages VC1, VCB1 and VCB2. Okay. I is your input current and VBE is your input voltage. So when you increase the voltage, the current is also increasing. If you taking different voltage value VCB1 and VCB2, this is your output voltage, you will get these kind of characteristics. Like this, you can draw output characteristic for common base configuration of SCR. So in common base configuration of SCR, the output current is your collector current and output voltage is your base collector voltage. So this is your output characteristic. This is your output current. VCB is your output voltage. You are taking different values of IE3, IE2, IE1, which is your input current and which is constant for one characteristic, right? So you will get this kind of characteristic in for common base transistor circuit. Now, common emitter configuration, which is very important. In many applications, this common emitter configuration is used for amplification and other applications, right? So it is very important. From the diagram, you can see in common emitter configuration that emitter is common between input and output. The input current is your base current and input voltage is your base and emitter voltage. But in the output current is your collector current, and output voltage is your collector emitter voltage. Like this, uh, common base and common collector, we can draw the input output characteristic of common emitter configurations. So you can see over here that the input voltage is your VBE, base emitter voltage, and input current is your base current. So we will draw input characteristic between IB and VBE, and you have to keep the output voltage constant, which is VCE. So your VCE is constant, VBE is varying with IB, or you can say IB is varying with VBE. This is your input current and this is your input voltage. This is your output voltage, which is constant. Okay, so this is the input characteristic for common emitter configuration of a transistor. Now, this is your output characteristic. So, output characteristic, as I told, that it is drawn between collector current and emitter collector voltage. So, you can see over here that in output characteristic, your output current is IC, which is your collector current, and output voltage is your VCE, which is your which is also your common emitter collector emitter voltage. Okay, and you can see over here that you have to kept input current constant. So for this characteristic, IB1 is constant. For this characteristic is IB2 is constant. For this characteristic, IB3 is constant. Okay, so this is your output characteristic of common emitter configuration. Now, what are the advantages of transistor? So transistor is a lower cost and smaller in size, smaller mechanical sensitivity, it has low operating cost, it has extremely long life, it has no power consumption, it has fast switching, it has better efficiency circuits can be developed, and it is used to develop a single integrated circuit, which is very important advantage of transistor, because in many circuits you see that on a single chip use you uh, see very complicated circuits. So transistor has a very important and a very big role in integrated circuit, or you can say in IC, because there are n number of transistor which is used to make a IC. So it is used to develop a single integrated circuit. Okay. So what are the limitations of transistor? So there are few limitations of transistor, which are follows. Transistor lack higher electron mobility. Transistor can be easily damaged when electrical and thermal event arise. For example, electrostatic discharge in handling. Transistors are affected by cosmic rays and radiations. So these are the few limitations of transistor. Now we will discuss about the application of transistor. So the core use of transistor include switching applications, or both as amplification and switching. So second application of transistor is there is a kind of transistors which produce current flow depending on the amount of light shined upon them. Those are known as phototransistors. Bipolar junction transistor can use a greater current flow from the emitter to collector when a small amount of current is passed through the base. So basically, BJT is a current controlling device or current controlling semiconductor device. So transistor is an active component and that is establishing in all over electronic circuits. They are used as amplifier and switching apparatus. As the amplifiers, they are used in high and low level frequency stages, oscillators, modulators, detectors, and in any circuit need to perform a function. So this is all about your transistor. So now we can revise once more that what we studied in this lecture. So in this lecture we studied about transistor. So transistor is a semiconductor device, right, which is very important. Second thing, it is made by two diodes, PN and PN junction. Okay, so it has three layers device and three terminal device. So three layer may be your PNP or NPN, but its three terminals are common. One is your base terminal, another one is your emitter terminal, and third one is your collector terminal. Okay, so transistor is basically a three layer and three terminal device. It is a semiconductor device. Okay, next, there are two type of transistor. One is your NPN transistor and another one is your PNP transistor. So we have already seen the different symbols of transistors. Uh, okay, and what what are the basic application of transistor which is used in switching and amplification? Suppose we are getting a signal from FM, but this signal has some disturbance. So you have to amplify the signal by using transistor. Amplification means that you are smoothing your signal or you are making that signal strong. So it can't disturb if you are it is traveling from for long distance. Okay. So transistor is basically a active component and which is used for amplification and switching. We have studied its characteristic because it has three configurations: common base, common collector, and common emitter. In common base configuration, the base terminal was common in both input and output. In common collector configuration, the collector terminal was common in both input and output. In common emitter configuration, the emitter terminal was common for input and output terminal. So there are three basic configuration of transistor. Now these are some few questions or few objectives which is based on this lecture. So it, if you go through this lecture, you will be able to understand these questions and you will be able to understand you will be able to understand these questions easily and to answer them. Okay, so your first question is: a transistor has one PN junction, two PN junctions, three PN junctions, and four PN junctions. So I have already told you that transistor has PN junctions, but it has two PN junctions. Okay, so it is made by two diodes. That is a transistor. So B is the right answer for that question. Now, second is your the number of depletion layers in a transistor. So I have already discussed about the depletion layer of transistor. It has one depletion layer in transistor, okay, between collector and base. The base of a transistor is, we have already discussed that the base of a transistor is doped. Means, is it heavily doped, moderately doped, lightly doped, or none of the above? So I already told you that the base of transistor is lightly doped. So the answer for this question will be C. C is your right option. The base of a transistor is lightly doped. Now, The element that has the biggest size in a transistor is. So, what are the biggest size in a transistor? Collector. I already told you collectors. What is the work of collector? Collector always collect the electrons which is coming through the emitter. Base I already told you that base is your controlling terminal. Okay, but emitter always emit the electrons. Okay, so the biggest size in a transistor is your emitter because it will emit the electrons which go from n layer to p layer. You can say from emitter to base. Okay, and some of those electrons combine with holes which is in base layer. That's why always base layer is kept lightly doped. And when number suppose there are 10 electrons which is going through emitter to base, some of them, two or three electrons will combine to the base, to the holes with the holes which is in the base, and remaining electrons will transfer or will come to the collector terminal. So the element that has the biggest size in a transistor is your emitter. So next question is your, in a PNP transistor, the current carriers are uh, acceptor ions, donor ions, free electrons, and holes. So in a PNP transistor, the current carriers will be holes because there are two p layers and one is your n layer. So we will discuss about it in detail in the next lecture. What is PNP transistor? So holes are the charge carriers in PNP transistor. Next is your, the collector of a transistor is. So I already told you the collector of a transistor is it heavily doped, moderately doped, lightly doped, or none of the above. So the heavily doped layer in transistor is your emitter, the lightly doped layer is your base, and the moderately doped layer is your collector. Okay, so the right answer for this question is your B. Now, next question. A transistor is a operated device. So I already told you that the current flowing into the transistor is just because of your electrons. Okay, and the controlling terminal is your base. If you can control the base current, if you can control the base current, then you can easily control the output voltage of the transistor. So the options are given: current, voltage, both voltage and current, and none of the above. So the right answer is your current because transistor is a current operated device. Now, in a NPN transistor are the minority carriers, because in NPN transistor you can see that there are two N layers, and N type semiconductor means there are large number of electrons than holes. So minority carrier NPN in NPN transistor will be holes. So the options are given: free electrons, holes, donor ions, acceptor ions. So the holes will be the right answer for this question. Now, second question, next question. What is the emitter of a transistor is doped? Emitter of a transistor is doped. I have already told you the highly doped layer. There are three layers: base, collector, emitter. So the highly doped layer in transistor is your emitter. So the options are given. One is your lightly, second is your heavily, C is your moderately, and D is none of the above. So emitter is your heavily doped layer or terminal. Okay. So the right answer for this question is your B. Now, in a transistor, the base current is about of emitter current, because you know that the emitter is highly doped layer, so number of electrons will be more in emitter than base layer, and base layer is already lightly doped. So where are so if a number of electrons is more than in emitter side, the current will be more in emitter layer as compared to base current. So the emitter current will be large as compared to base current. So the options are given. A option is your 25%, B is your 20%, C is your 35%, and fourth is your 5%. So the correct answer is your 5%. Okay. So these are the objective questions which is based on your lecture. So this is all about your transistor. Once we can revise in 1 or 2 more minutes that what is transistor. Transistor is a semiconductor device. It has three layers and three terminals. Three terminals are your base, collector, and emitter terminal. Emitter is your heavily doped layer. Base is your lightly doped layer. Collector is your moderately doped layer. Okay, it has three configurations: common collector, common base, and common emitter. We have already drawn the characteristic for these three configurations, which is input characteristics and output characteristic. Input characteristic is always drawn between input current and input voltage, and we have to keep output voltage constant. And output characteristic is always drawn between output current and output voltage, and you have to keep input current is constant. Okay, and there are n number of applications of transistor. The most important application of transistor is your in switching and amplification, and the third one is your in IC or integrated circuits. And there were some few limitations, okay, because it is very temperature sensitive. If you apply more temperature, it will get damaged. Okay, so this is all about your transistor. If you have any question, you can ask me in the next lecture or in this lecture. Thank you.